Okay, so recording is started. So I'll start discussing the content for now. Okay, guys. So welcome to DSSCP Algo Week 1. We'll be going through a bit of orientation, talking about the team, and we'll move to content. This should take not more than 15 minutes. In case my voice is not clear, do let me know. So this is the team. Hi, I am Gaurav, and I am the lead for DSSCP. With me, there are two more people. Meet and Viksha. Both those are sub leads along with me. In case you want to follow any of us on LinkedIn, that's an option. We have pasted our QRs. Don't worry, in case you're not able to do that right now, we'll share all the PPTs as mentioned in the brochure by 10 p.m. By 10 a.m. tomorrow morning. So you don't have to worry. We have a couple more people. So we have Suhavni Pandey from AIML first year. We have Roshan and Vivek. Roshan is from CSE and Vivek is from AIML second years. And then we have Niharika from third year, Nitin from second year AIML, and then we have Nitish from third year CSE. Again, the QR codes are available. You can scan them to follow us on LinkedIn. We're sharing the PPT later on. Moving on, let me talk about our mission, because this is the first chapter of Google Developers Group in our campus, and this is the first time we have launched something as DSA-CP. The primary reason being DSA plays an important part. So we want to build a beginner-friendly pathway and with analogies and mentorship for modular challenges. Uh, we want to inculcate DSA into real-world algorithms. A lot of products we use today are actually make a subtle use of DSA and algorithm concepts, using certain things such as keeping things on top of each other with help of stacks, or using queues for for example, ticket counter. There are a variety of examples, as in when you learn DSA, things will become more clear. So we want to teach this not only from problem solving perspective, also so that you can use that for your own products and then your own projects. Yeah, moving on to that, what is CP? Now you might not be aware about what is CP. So we want to foster collaborative contest and strategy breakdowns with peer-led growth. CP is basically a gamified version of things. So you have DSA wherein you have problems and then you're solving them. CP stands for competitive programming, wherein you are adding strict constraints such as this problem has to be done within, let's say, 1 millisecond, or like when it executes, or for example, the memory, it should not use more than a certain amount of memory, and teams compete with each other under a strict time limit that you have to solve, let's say, this many problems within 3 hours, and whoever does it the best and the fastest gets ranked higher. And yeah, so this is called a CP. And if you are interested in CP, you could start with any programming language. After that, you can move on to learning DSA. Side by side, or right after you are done with DSA, you can start preparing for CP, which is a more intense form of DSA. And once you are done with that, you can go for competitions. And in case you are interested in in national and international level competitions, that brings us to something called as ICPC. Now, ICPC is a global competition wherein you participate as teams representing your college. So team sizes are generally 3 to 4. You would participate in teams of 3 to 4 with one extra member. This is the rule as of last I remember. And yeah, you participate as that, represented by your you represent your college, and you also have one faculty member as your mentor. So basically, we will try to move on to this eventually. We want to set the stepping stones for this in our college, so that students can go through all of these and then eventually target ICPC, because we don't have a team from our college currently. Yeah, so this is why ICPC, because here are a few things you can. First of all, if you win in your college, let's say if you are winning in your college, that has an edge. You can put that on your resumes. You can also put that for future education, higher education. Let's say if you are winning regionals, or let's say if you are winning nationals, that's a very big deal. That increases getting hired, or these abroad. And let's say you somehow you make it up to the international scale. what happens at that point? Even if you don't win there, because you have qualified for the camp and reached over there, your resume, I mean, you would be pretty much considered as a top tier candidate in programming and data structures. To reach there, you would be pretty clear with the concepts and other stuff. And yeah, as mentioned, DSA is one of the major requirements for hiring. So a lot of students in our college would be, interested in hiring or placements. So this is one reason to target DSA and CP. Your only goal, for now, you can target a programming language followed by DSA. You don't have to learn everything in that programming language, just enough for DSA. In case you want to target higher, companies offering higher salaries like 30, 35, then you have to go for the, more advanced versions of DSA, or it would be better if you went for CP. And obviously, competitions are available as and when you progress. So yeah, this is about our mission. We want to inculcate this habit in our college so that, students can start this early on. To get any more information about our events, in case anyone over here hasn't yet joined our info board, the QR code is available. Our brochure is also available. I'll go through that. Please share this among your friends and join this in case you want to stay updated with this. Moving on, give me 1 second. Does anyone have any questions so far? Any questions? No, right. All right, then I'll move on and then I'll discuss the brochure for now. So this is the AlgoWeek brochure, and I won't go through everything. I guess people would have seen a lot of this. I'll talk about a few things such as a schedule and other stuff. So if you look over here, today we are going to cover the meet the team and then time complexity, space complexity, and some basic stuff with arrays and vectors. And then this is the syllabus for the next 4 days. Finally, we will have a final assessment on Monday next week. The assessment format and exact structure would be shared pretty soon. And every day, right after we are done with our workshop, we would have a quiz wherein we would. I'll discuss that as well. Now, talking about rewards. So, if you attend all the 5 days of workshops as well as the quiz, you will receive a participation certificate, and you also have to take part in the final assessment. The top winner for any given day gets a branded mug. So this is for the workshop days. So day 1 to 5, we will have the quiz. Whoever ranks at the top over there gets that branded mug. Talking about the final assessment, top three winners would get a certificate of it. The first place person gets a branded hoodie. The next person gets a branded water bottle, and the third person gets a notepad as well as a pen. About the guidelines, I guess people are pretty clear with this. You have to attend both the quiz as well as the session to be marked as present. And yeah, moving on to the quiz format, this is more important. Right after our workshop, we will share some links. There are 3 breakout rooms to accommodate everyone. Assuming we would have more than 100 people, we have made 3 breakout rooms just in case. And yeah, so you can join only one of those rooms, and this is the name format with which you should join, USN_name, because we need to recognize who is the person who is ranking at the top. If you don't do this, we will remove your name from the attendance and consideration for the prize, even if you win. So yeah, keep that in mind. There will be 20 questions, each of 15 seconds. These will be MCQ questions on Slido. Again, there will be a 15-second pause between questions, so we can show our leaderboard as well as the progress at that point. And questions will be released one by one from our team. There is no option to go back to any previous questions. After each of the rounds, we will share the rankings. There will be 3 breakout rooms. So these are not final rankings in case we go with all the rooms. The final rankings will be shared by 9 p.m. every day. So like for today, it would be shared by 9. You don't have to log into anything. You just have to go through the quiz link. And again, final assessment, as I mentioned, the rules may differ. We'll share that. Regarding eligibility, we have kept it such that only first and second year students are eligible for prizes. So third and fourth year students can join. They can take part in quiz. They will get the certificates and all, but they won't get the certificate of achievement or a prize. To make this fair, because a lot of students start placement preparation, so they would be a little ahead compared to first and second year students. We'll make use of PPTs, live coding through Suitable Editor and Lead Code, and we'll also use annotations. As you might have seen on the other PPT, I used a pen to draw certain things, right? So yeah, basically that. And we will share the materials the next day around 10 a.m. along with some extra questions for you to try out, though it won't affect your leaderboards or rankings. They are purely for you to try out and maybe try your skills that you learned. Additional guidelines, again, you can go these things. Everyone knows about this. And yes, once more, if you want to join our info board, this is the QR code in case you are not a part of the info board already. Okay. At this point, does anyone have any questions? No, right? Uh, Vikas. Yes, Vikas. Do you have any questions?
It should be like install C++ compiler, right? Is VS Code fine
You
for today's session?
you can try MinGW as a compiler. For the current session, let me show you something. You don't require any offline compiler or a VS Code. We have made it such that you can do everything online. So if I go over here, this is one compiler. So you can go to online GDB and then you can go over here and we will be covering our material in C++, by the way. So yeah, you can
Uh,
go over here and then you can select your language. So let's say I go with C++. I'll get this boilerplate code. I'll remove this for now because I want to teach stuff. And yeah, you can code along over here because if you look at lead code, right, the material over there, you only
uh,
have to write your code. You don't have to write everything. Got it?
okay. So
Yeah,
today,
does
that can you please share again?
the name of the website?
Yeah, yeah.
It's in the chat. Someone has sent it already. You can click on that and select C++ over there.
Uh, Actually,
Is
I
it
joined now. It's deleted actually.
okay? Will Meet, can you share this again in the chat? See, there will be this option called as chat. Go on that and you will get the link. Click on that and select C++ compiler. That should do it. Are there anyone? I'll take only one more question and then I'll move on to the content. Is
Is
that
it
fine, Vika?
GDB online compiler?
Yes, yes.
Okay.
Is this fine? No more doubts for now. And so yeah, okay. Fine. Then I'll move on to the actual content. So, hmm, right. Just give me 1 second. Okay. So this is the day one of Algo week. We will be covering certain materials. Now, this is the team for today. Again, I am Gaurav. I am the lead for GDGDSSCP. I will be instructing you today. I'll be teaching material at any point. If you have any doubts, please type them in the chat. One of our teammates would let me know because I can't see the chat while I'm teaching. Along with me, there is Suhavni Pandey from the members, and she is going to assist me with setup and other things. Our QR codes are available over here in case you want to follow us on LinkedIn. Moving on, this is the syllabus for today. So there are 5 things which we will discuss. First thing is time complexity. Next one is space complexity, followed by 1D arrays, vectors. Finally, we will have a quiz. Now, talking about time complexity, what is time complexity? I'll go through the definition first and then I'll explain it on a separate slide. If you look into the background, it measures time as a function of input size. Now, this might not make a lot of sense. And yeah, and a few more definitions. It actually counts the steps, not the actual time of execution. Finally, there is a relationship for time complexity, input 2 minus input 1 divided by time 2 minus time 1. Now, what does this mean? Let me talk about this. Let's say I have a laptop and I have a C++ program. Let's say this C++ program runs in 5 seconds in my first device. Let's say I have another laptop. I have another C++ program. Again, this C++ program is the same as my first one, exact same copy. But on this device, it runs in 10 seconds. Does this mean that the code on machine 1 was better than the code on machine 2? No. The code on both the machines as mentioned by me was exactly same. The only difference could be that maybe my machine one has more RAM, maybe it has more storage, maybe that is the reason why it ran faster. And in the second machine, maybe my device is slightly older, and maybe this is the reason why it ran in 10 seconds. If you try to take this code from here to here, it will run in same time. Again, if you take it from here to here under identical conditions, it would run in 5 seconds instead of 10 seconds. So this means that when we are measuring time complexity, this explains the second point. We are not actually measuring the time. Now this might confuse you, so let us take a simple example. Let's say everyone, I think, let's say if you have to count from 1 to 100, what will you do? Let's say this is your program to from 1 to 100. Make this n instead of 100. You don't know the upper limit. What will I do? First, I will read some value n. What will I do next? I will set up a counter. This counter will start at 1. Now, I will make sure that my counter goes till n. So this will be like 1, 2, 3, so on up until n. Let's say if this will go up till 100. So these are the number of steps. Finally, I am done. So I am exiting. Let's say our 0th step is start. Now, excluding the start step and the exit step, these are the steps that are actually doing my work, right? So let's say this contributes one step. Setting up a counter, this takes one more step. Now my counter actually moving from 1 to 100, this will take how many? This will take 100 steps, right? So how many steps did I move? 100 plus 1, 1 from this, and then 1 from here, and then 100 from here. This means I had 102 steps. Now, what about a situation wherein my n was, let's say, 10 power 6? In that case, I would have 10 power 6 steps for the counter, one for reading the size of the counter, and one for actually setting up the counter. Assuming this value can change every time, I can say I had to run my counter for n steps, and I had to read my value one time and then set up things one time. So this would mean I had to actually work for n plus 2 times. Do you not think that the time for a program to execute would depend on this n? Take a simple task. Let's say you get a punishment. Write I won't repeat this 5 times versus write I won't repeat this 500 times. You would take less time to do this, would take more time to do this. This is a pretty simple analogy to understand, and from this you can understand that a uniform and better way to decide what affects the efficiency of my program is time is not time, it is the number of steps. But in practice, to make things easier to understand, we mentioned that we are measuring the time complexity. That is why I have said that first of all, you don't count the actual time, you count the steps which you had, and the time for which your program ran depended upon how much work it had to do. What was the input that it got? If it was asked to do something only for 10 times, it would do it 10 times. If the task was asked to be done 100 times, it would do it 100 times. Consequently, the amount of efficiency of my program varies. Now, what about a situation wherein I want to compare two devices? Now I talked about device 1 and device 2. What do I do in such a situation? Just give me 1 second. Okay. So, yes, moving back, this graph might be a little confusing. So let's say I say that for input 1, let's say I gave input 5 and I took 10 seconds. I gave input size of 20. This is, let's say, the input, and this is the time. For some input 20, I got what? I got, let's say, time 40. Now this gives me a linear relationship, right? If I try to plot this, I will see that I have a linear graph. Now we all know that if we have a linear graph and we try to find the tan theta, that should be constant, right? So if my program for 5 input size, it gives me 10 seconds, then for 20, it will give me 40 seconds. And this relationship is consequently the same on next machine. So in the next machine, what did I find? Uh, my tan theta is let's say 10 is let's say 10 by 5, is not 10 by 5. I don't remember the exact formula, but in either way, I guess you get the point. Right. So let's say over here, for input size 2.5, it runs in time 5, and for input size 10, it runs in time 20. What does this mean? For the next machine, my relationship is same because my tan theta is same. The basic idea about this. So if my input is represented on the x-axis and my uh, you know uh, my time taken is represented on the y-axis, I can plot a graph to see the ratio between the two of these. Getting this, let's say this was input 2 and input 1, this was time 2 and time 1. What will I get? I2 minus I1 by time 2 minus time 1. This ratio should be constant across the machines for any given program. So this C++ program and this C++ program are identical only if this ratio is same. Now this might be a little difficult to understand because there is math involved in this. Forget about that. For now, just think that if I have same program, it might run for different amount of times in both machines, but the efficiency is same. Why? Because as I told, we don't count the time, we count the steps. Moving on. So there are certain notations to represent things. Let me clear up things a little bit. Right. So if I move on and go to full screen. Okay. So what about this? The note. Now we know there are certain metric systems. So if I talk about distance is represented in kilometers. It is also represented in miles, right? So there are different ways to denote things. If we talk about standard physics, forget about physics. We are talking about time complexity. There are three ways to denote things. So let me give you an example. Let's say there were two people, and the two people planned a birthday party, a surprise birthday party for the third friend. Okay, and they told that you have to come to some place for 6 and we'll stay till 8. So 6 p.m. to 8 p.m. Let's say this was the time. Best situation is this person reaches on time, this person reaches on time. Assume person was already over there. Okay, so this is the best situation. Both of them reach on time, both of them hang out with this guy for 2 hours, and after they are done, they leave. Right? This is the best case scenario wherein everything goes as you want it to. This is represented by a notation in computer science called as the big omega notation, or simply put, the omega notation. What does this mean? This represents the lower bound of growth rate. I told, right, your function, your program can run for certain number of steps depending upon what case happens. This can be the best case situation, which is represented by this. And if it is the best case, obviously the amount of time which it takes is least, right? And least time means lower bound. If we take a graph, lower bound basically represents the least time, not strictly speaking, but yeah. And this is used to represent the best case scenario. Now what about another scenario? Let's say again there were two guys and they planned a surprise birthday party for this guy from 6 to 8 p.m. Assume this guy reaches on time, but this guy takes a detour and then he reaches over there, let's say at 7 p.m. This is not ideal, right? So this is, I mean, one person reached on time, another person did not reach on time. This is an average scenario, right? So this is what happens in practice with most of our code in the systems and at industrial level as well. We will mostly never see the best case scenario and worst case scenario. We will usually be working with the average scenario. Obviously both are possible, both do happen, but when we talk about complexity, we generally uh, by in practice in industry talk about the average case scenario. How do you denote it? You denote it through something called as theta. Now, when we talk about an algorithm, which one do we use in computer science mostly? Right? That is called as big O notation. Assume a situation wherein this guy, these two called this person at 6 o'clock. Now this person reached at 8 o'clock. This person also reached at, let's say, 8:30. By that time, this guy left. Right? Neither of them reached on time, and the third person for whom the birthday party was there also left. Now that person's mood was spoiled, and these two felt guilty. So this is the worst that can happen in this situation, right? This in practice represents the worst case scenario. Why do we care about the worst case scenario? Whenever we write something, right, if we try to plot it, we will see three types of situation. One situation is, let's say this was my idea. One situation is something going very bad, and another situation is something happening properly. Ignore the graph for now, but basically, if you find the worst that can happen, you can always expect better. You know that nothing can go beyond this, nothing can happen worse than this, right? So whenever we are coding, whenever we are writing our algorithm, we use big O notation to find our worst case scenario. Nothing can go beyond that, and if it is the worst case, it means it should take the maximum amount of time. So this means this is the upper bound of growth rate. It represents the worst case scenario. And again, as I mentioned, okay, so this may or may not be the direct function of input. Now this might confuse you, I'll explain this as well. And this is useful for denoting other scenarios as well. Again, you can use big O to represent average scene as well. You can best scene as well. You can also use it to represent an average scene. But if you put it this way, for the different notations, it's usually easier to understand. When would you use this? In case you want to draw a relationship between the worst and average case, in such a situation, you could maybe use this. Now, talking about this is not always a direct function of input. Let's say my program is program to print even numbers between 0 to n. So for this, I will pass a value n. First thing, what will I do? I'll read n. Next thing, I'll set counter to 0. Third thing, I will increment my counter in steps of 2. What does this mean? First, I will read 2. First, I will have 0. Then I'll have 2. Then I'll have 4. And so on till n, assuming n is even. So if let's say n was 100, I will go from 0 to 4 till 100. In case n was 101, again we would have gone till 100 only because we wanted only the even numbers. Finally, so these are the three steps. Again, we had start and stop. Let's not care about those. So we had one step for reading. We had one step for setting the counter. What about this? You would have thought that since input size was n, okay, input mentions, you would have had n n steps because of this counter. No, since you are only checking the even numbers, you are avoiding the odd numbers, right? So this means you're actually working for n by 2 steps. What does this mean? Your actual program was not affected by the input directly. It was still dependent upon your input, but it didn't depend on it directly. This is what I mean by this, that your function may not always depend upon input. This might be a little difficult to understand right now, but when you start solving problems, you will see scenarios where things work a little differently. So I won't go in depth into this. Let us now use this graph. These are some different types of time complexities. As I mentioned, there are different types of programs, right? So O of 1, this is the best. It means you are getting something directly. Again, not this may be misleading. Why? Because as you can see this graph, beyond this green line, all the other graphs are actually performing better, right? Because for that given input, they are giving lesser time. It is above that these values are performing worse than O of 1. O being the worst case scenario. And then we have log n, O n, and log n. Again, I won't go too deep into this because it would get confusing. In case you want to see the hierarchy, this is the hierarchy wherein O of 1 is usually considered the best time complexity, and O of n factorial is considered the worst time complexity. There are certain things like descriptions and examples. I won't bore you guys with this thing because again, this comes with a lot of practice. So moving on, if I jump on to certain rules for time complexity. So like let's say if you were solving a question in mathematics, let's say if you were talking about integration, you remember how we used to first learn about some steps, and then for example you could also write this as 1 0 and then minus x dx or something like that. I don't remember exactly, but there were certain steps for certain rules which you had to keep in mind while solving any problem. That goes for time complexity as well. Whenever you are solving time complexity, you will have to keep certain things in mind. Count operations, not the real time, as mentioned here. When we are doing counting the number of steps, so over here we have 1 plus 1 plus n by 2. Why? Because we are counting only the even numbers. So we have 2 n by 2, and this is my worst case time complexity. Now, so this takes care of that. We don't actual time. Sequential code, add complexities, then keep the largest. What does this mean? Let's say I have a program. First it counts from 1 to 1. Okay, what does it do then? It let's say it finds the odd numbers. Third thing, what does it do? Third thing, it prints 5. Now, what would these contribute? As you remember from the previous examples, this would take, let's say, 100 steps or near about n, if n was the size of the counter. Now, for printing odd numbers, as mentioned, it would be the same as even numbers. This would take about n by 2 steps. And for just printing 5 one time, this would take 1 step, right? So I'm getting O of n plus n by 2 plus 1. What does this give me? This gives me O of 3 by 2n plus 1. Simple mathematics. So this is the actual time of my code. Assume all other steps are not there. These are the only 3 steps in your program. I'm not concerned about reading and final output. Okay. So in such a situation, what do we do? If my code is sequential, first I am counting. After counting is done, then I'm finding odds. After that is done, I am printing 5. Then add this individual complexity. For the first one, it was n, then n by 2, and then 1. After we have this, which is the largest one? Or if you could have seen this one, which one was the largest? N was the largest. So ignore this, ignore this. You could have simply written O of n. One more thing is recursion. I won't go into recursion for now because recursion is a slightly challenging topic. If you're not comfortable with the basics of programming and DSA, it might be a little difficult to understand. You can check this out later on different platforms how recursion works. In case you still have doubts about the time complexity for recursion, then you can reach out to us. We'll help you out with that. Now, talking about the fourth step, dropping of lower order terms. So let's say I had a program where the first part contributed n square and the next part contributed n. According to my second step, keep the largest of the complexities. Which will largest? N square. I'll keep this. Why? Because assume a situation wherein n is, let's say, 1 million. Now 1 million square is a very large number. On the other hand, 1 million is a very small number, right? So you can say, we'll see this in mathematics often, that if some value k is very small compared to another value x, we make it inconsequential. So if my equation was like, for example, a is equal to bx plus k, and if k was very small compared to x, I'll ignore this and I'll simply write a is equal to bx. It's kind of similar to that. So we will drop the lower order terms. Okay. Again, n square might, and you have to compare which one is relatively more important. If, for example, this was like O of k square plus n, and the maximum value of k was, let's say, 2, but n was 5 to 50, then of course 2 square is the max. 2 square would be the maximum value would be 4, and in situation n should be more important, right? So if you are confused, you can leave this be like this. Otherwise, if you have clear idea about the range of values, because usually you will get constraints. For example, k is in the range of 1 to 50, and then let's say 1 to 50 is the range, 1 to 500 is the range of n. So you would be pretty clear about which one to drop. Yeah. Moving on, constants can be dropped as well, because if you see a graph like n, another graph like 3n, it's only that the theta changes, right? Only the slope changes, basic mathematics. So if you have a constant, you can drop that. If you have something like a is equal to bx over here, b is a constant, x is the term affecting, so I can simply write a is equal to x. So x is my complexity. Moving on, if I talk about constant time operations such as index access, arithmetic access, and assignments. For example, if we take the previous example of, let's say, int x is equal to 50. What are we doing over here? We are assigning a value of 50. This takes only one step. For such a situation, the complexity of this step is O of 1. What about index access? You might know about arrays. So if I have an array and I have certain values, to get that value, I will, let's say, do int v is equal to arr of I. This will give me the value at ith index and store it in this. I'm just accessing it one time. And since this is an array and I know the position, I'm directly getting it. So the complexity in such a situation is also O of 1. This is what I mean by constant time operations. And as mentioned, you should care about the worst case scenarios in most situations. Obviously, you can also compare the best and average case scenario. Now, when would you do that? Let us say I have three pieces of code: code A, code B, and code C. Let's say the worst case scenario for all of these is O of n square. Now I am confused. Which one do I pick? In such a situation, I can try to find out the average and the worst case scenario. Why? Because I know this is going to be my worst case scenario. If I can find out which one has a better average or best case scenario, maybe I can shortlist. So let's say A and B offer a better best case scenario compared to C. So I'll eliminate C. Now what next? Now I'll check the average. Of these two, A offers the best average case scenario. So A is my final winner. You might see this while you're trying to optimize your code and try to improve the efficiency. Moving on. So I think this clears the part about time complexity. At this point, does anyone have any doubts? If yes, please let us know in the chat. I'll wait for one more minute and then I'll move on to the next topic. Nothing? All right. Moving on. Space complexity. As mentioned, time is one of the factors. So assume this situation. Space complexity is about the memory you use. Let's say a lot of people are waiting for GTA 6, right? And all of us know that this is going to use a lot of CPU and this is going to use a lot of memory as well, right? So means that how well your game runs on your system depends upon the amount of CPU and memory you have. You can generally link CPU to your time complexity and your memory to your space complexity. Now, not exactly, but just as an analogy. So assume this situation: when we are talking about any code, we are concerned about not just the time for which it runs or the number of steps for which it runs, but also the amount of memory it hogs from my system. If it is taking too much space in my memory or too much, available registers, it is too difficult for me to do anything. On the other hand, if it is using less space, it is good for me. Now, when we do something, we have two types of memory. We have the input memory as well as the auxiliary memory. Talking about this, now let's say that previous question about, given a value n, try to find all the odd numbers. So this contributed a space of, let's say I am given a grid 0, 1, 2, 3, 4, 5, 6, 7, 8. Let's say I have this grid. This is a 3 cross 3 grid. Now this occupies how much space? 9. 9 in total if you count only the cells. This would be my input memory if this is the grid given to me. Now let's say I want to take the transpose of this and store it in another grid. What will I do? 0, 1, 2, 3, 4, 5, 6, 7, 8. I don't want to modify my original grid, so I'll create a new grid and I'll store it over there. Now, this also offers a total space of, this also requires a total space of 9. This is called my auxiliary space. Any space which is provided to me as my input is consumed by my input is the input space, as and any space which I use within my program to store something because of to solve something or to return something, that is my auxiliary space, which is the extra memory used by my algorithm. So if you take this GTA analogy, right, input space would be, let's say the file is of like, let's say 60 GBs, right? So that would be your input space, for example. And then as you run your app, you would have certain, it would create certain files and store it on your system. So to run efficiently, it would do that. So let's say it takes 5 GB of space. So that would be your auxiliary space. Now, not exactly, I'm just giving an analogy. So moving on, rules for space complexity is pretty much similar to time complexity. We have certain rules for denoting things. Any extra memory used instead, apart from the auxiliary space, is not counted. So as you can see, this in this GTA example, this 60 GB is non-negotiable. I can't do anything about this. This will be there. This 5 GB, I can work on this. I can maybe try to keep it less. Maybe I can keep it as 3 GB or something. So yeah, whenever we are writing our program, if we are given a certain input of, let's say, nine things, right, or 100 things, we can generally not do anything about that. It is only our algorithm and the space which my algorithm consumes about which I can do something. So it is a practice that for extra memory, we don't count the input. We only count the space which my algorithm uses, extra space my algorithm uses. So if take an example of reading a number n and then storing all values from 0 to n. We have that example as well. That is about this one. So if, let's say, I read n and then I store the 0 to n minus 1, 0, 1, 2, so on. So there will be a variable n which will take a space of 1, and then there will be which would store 100 values. So this would take a space of 100, or should I call it n? So any variable or constant uses an O of one space, as mentioned over here, and any array or list uses an O of n space. Again, we can have nested arrays, nested lists. Let's not talk about that. Okay, fourth point does mention that. So nested data structures. Talk about my matrix. If, let's say, this was not 3 cross 3, if I talk about a normal matrix, it could be m. So if I created a new matrix of m cross n within my system, then the space would be O of m cross n. Why am I using O? This is the worst case scenario. Again, as I mentioned over here, your big O notation is quite versatile and can also represent space complexity. It's just a mathematical notation. Again, recursive algorithms, let's not go into this, but know this, that recursive algorithms add to some space. And talking about iterative algorithms, these are your basic algorithms using loops. What is a loop? It basically does a set of things until the condition is true. So iterative algorithms use O of one extra space y because I don't have to store anything anywhere. Within the loop, I might be doing something of storage, that's different, but the loop in itself doesn't require any extra space. Dropping of constants, as we have discussed in the previous time complexity scenario, we drop the lower order terms because they don't usually, as in mathematics, you can avoid the values which are contributing very less. So let's say n square plus m plus k was my value, where n and m are variables and k is some constant. So we will see which one contributes the most. You will see n is much bigger than k, n square, so I'll drop k. Again, n square is much bigger than m, so I'll drop that. So what will you have finally? You will have O of n square as your final space complexity. If you are confused, like in time complexity, keep, or if you are given some constraints, then you can use that to determine which one to drop and which one to keep. So these are the rules for space complexity. Now talking about the time space trade-off, this is very important because there is a balance. Sometimes you have to sacrifice your space to save time. Sometimes you have to sacrifice your space to sometimes you have to sacrifice your time to save space. Now What about this? Assume a simple scenario. I think Adobe Photoshop is, a pretty popular tool for photo editing. We also have GIMP. Now, GIMP is popularly used for photo editing as well as drawing, etc. Depends on what you want to do. You would have seen that this is very resource intensive. On the other hand, this is very light. What does this mean? Over here, I am sacrificing certain things. Over here, I'm sacrificing certain other things. If I take a simple example, let's not take this example as well. Let's say if I take the example of my matrix transpose. If this was my matrix and I had to take the transpose, and to save time, I was using extra 1, 2, 3, 4, 5, 6, 7, 8. This would be my new matrix, and I could directly put this row into this column, this row into this column, this row into this column, right? On the other hand, let's say I did not want to use this extra space. If I tried to manipulate it over here, by the way, in this example, you can do it without creating an extra space. But if I had such a situation where, I had to sacrifice one of these things, only GB of RAM, but I have, let's say, 1 TB of SSD, I would be more willing to sacrifice my storage rather than my RAM. So I'm more willing to sacrifice the memory rather than my CPU time. On the other hand, if I have a system wherein I have 32 GB RAM, but I only have 64 GB SSD, in such a situation, I can't sacrifice my storage. I have to sacrifice a bit of my time. This is that trade-off. At times, you have to, uh, sacrifice your space to save on time, and the vice versa. Now, how would you generally do that? To save time, you would generally pre-compute result and then you'd use it directly as in when you need. This is, by the way, a common concept in something called as dynamic programming, which is a very advanced concept in DSA. But yeah, it saves time by using this thing. On the other hand, we have recalculating every time we need something. So this could generally be attributed to your recursive approach, or an approach wherein you don't care about storage, you just want the result. So you check out every single path. I won't go in depth into this, but yes, you will see algorithms wherein you are, to optimize some things, you are moving from, let's say, if you have O of n square time and O of one space, to save on time, you are getting O of n time and O of n space. So this would be a scenario. You can explore this on your own, or while the others are teaching on the other days, you can ask, you can view this for yourselves. But yeah, this is there. Moving on to talk about arrays. Is everyone clear about the space complexity bit? Okay. Please summarize this time space trade-off. Okay. Basically, if I am okay with sacrificing some space to make sure that my CPU is not, getting overloaded, I will use some space and store values from previous calculations. And every time I need those values, I will directly use that instead of calculating it again. On the other hand, if I am more concerned about my CPU, more concerned about my CPU, about my space, right? Then I will not burden my space. Every time I need some value, I will calculate it and then I'll use it. A simple example, Fibonacci series. If you have written Fibonacci series code, you need the second last and the last element to find the next element. Everything in an array, you would have, taken the example of uh, time space trade-off. So you are using space to make sure you don't sacrifice your time. On the other hand, every time you have to find nth Fibonacci number, if you are calculating every previous value, that is an example of sacrificing your time to make sure you save on your space. Is this clear now? Satvik, is this clear? Okay. Moving on, I'll talk about today's session might extend a little bit, beyond 7 o'clock because we have certain concepts we want to talk about. So bear with us for a while. Arrays, I'll go through this quickly. Arrays are containers which are used to store values sequentially. Okay, contiguous storage, fixed size, of axis. What does this mean? In memory, 0, 1, 2, 3, 4, 5, 6. If these are the array indices, these are right after each other. If I go from 0 to 1, I will directly get that value. After 1, I will directly have 2. After 2, I'll directly have third position. It's like a traditional file system. If you have a folder in which you are keeping all your files at home, there are 15 compartments. The zeroth compartment has something, right after that the first compartment has something. It's like that, everything is one after the other. And to get some value at that, you find that compartment number in that file, and with that you get that value. So fixed size, again, your folder which you have at home, you cannot magically add 10 new compartments into that. That is fixed. That's kind of like arrays. Once you have allocated a size, it is fixed. If you want to find a file from that folder, you just want to know the container, the position number, and you'll directly get that. That is kind of similar to arrays. O of one axis, you don't have to check. Okay, to get over here, you don't have to first check, then this, then this, then this. As long as you know the position, you directly get that. Talking about the range, if my array size is n, it is a convention in C++ to start my array at the 0th index, the first cell, and the last cell goes up till n-1th position. So if 6 was my size, my starting index would be 0 and my ending index would be 5th. So make sure you use this range whenever you're working with your arrays to make sure you avoid any undefined behavior. Moving on to syntaxes, declaration and initialization. Int arri. Int is the data type. I'm assuming you guys know about data types such as character, string, boolean, etc. Arr is the name, and this specifies the size. Now, in a situation where I don't know the size, but I just want to fill it with some values, I'll do this and I'll simply write those values. Another situation, I know the size, I name the array, and I fill it with elements. When would I do this? Let's say I know that my array size should be 10, but I only want to fill 5 elements right now. I will do what? I will do arr size. So let's say 10 is equal to 1, 2, 3, 4, 5. Okay. And then the remaining spaces, as you can see over here, this array size is 6, but only 3 spaces are filled. 19, 10, and 8. By default, C++ uses a garbage value. What is a garbage value? It is a default value which is put when nothing is specified. In C++, it's 0. So every other compartment for that 0 was put. Updation, you specify the array name, the position at which you want to put the value or update the value, and you specify the value, the new value, or the the current value to put. How to access something? You specify the array name and the index, you get that value, and then you can directly use that, or you can store it in some other variable. Talking about loops, this is the syntax for C++ loops. You specify a counter to keep track of every single position. You start at the 0th index, which is the 0th position. You go up till less than n. Why? Because 6th position is not valued. If my array size is 6, 5th position is the last valid position. So I go till right before 6, which is an integer 5. Every time I am done processing, I'll increment my counter I. So after 0, I will have I equals 1, then I'll have I equals 2, so on till I is equal to 5. This is my last position. What will I do? Every time I will print that. Cout is the syntax for printing, and arri means ith value. So arr of 0 would be 19, arr of 1 would be 10, arr of 2 would be 8. Assuming this was not x, this was an array arr. Now about the size, let's understand an analogy. Let's say I have a bag. This bag is of 20 kgs, and this bag has 4 more parcels, each of 5 kgs. If I want to find the number of parcels within my bag, let's say, so what will I do? I'll take the size of the weight of the bag and divide it with the size of each parcel. This will give me what? This will give me 4. It means I have 4 parcels within my bag. It's kind of like this. There is, for an array, there is no direct way to find the size. So what do I do? First, I find the size of the entire array. So let's say my array was of 32 bytes. Bytes is the unit used for storage space. And each of those cells within my array, like this, they were of 4 bytes. What does this mean? I have 8 sets. So if there is a situation where you want to find the size of your array, you'll do something like this. This takes care of what is an array. Moving on, we'll discuss a simple problem on 1D arrays. What does this do? The question asks, create an array of first n whole numbers. For anyone who doesn't know, whole numbers start from 0 up until infinity. And these are all integers. So it would be like 0, 1, 2, and so on till infinity. So I have to create an array and store n whole numbers. So if n is equal to 10, first n whole numbers are 0, 1, so on up till 9. So I have to store these values in my array and print that array. What to do next? I have to take this array and double all these values in the same array and print the updated array. So I have to convert this to 0 to so on up until 18, and then I have to print this. Let's look at the question breakdown. You need to create an array that contains n whole numbers, so 0 till n minus 1. Then you print this array. After that, you update the same array as per the question by using this logic. How does this work? If let's say a was equal to 5, b was equal to 2 into a, this means 10. This means I could have written, if I have to simplify this, I can write a is equal to 5, a is equal to 2 into a. This will use the older value of a, and what will this do? A is equal to 2 into 5, which is 10. Kind of like that. So I'll find the ith value in that array, I'll double that and make it the new value of that array. One second. Moving on. So this is about, updation. Then you finally print that. What does this question check? Array creation. You get to learn how to create an array, how to move through an array, because you have to access each and every element while you are doing this. Also while you are storing this. Accessing values with this method, ARR of I is the access, and modification, because you're multiplying it to the old value and storing it as the new value over there. Constraints for this question, there are no constraints. You can take it as anything. Let's say 10 to the power 5 is the maximum value of that array size, and let's say 1 is the minimum size. Real world example, you have a list of product IDs, seat numbers, indexes, etc., and you want to multiply. For example, let's say you have a company database and every person has a certain salary. Going into the new fiscal year, you want to make their salary 1.1 times of their old salary. So you'll access that value, make it 1.1 times the old, and make it the new value. Right? It's kind of like this. First, you generate these scores and then you apply transformation. How to solve? First, we will read n, then we'll create an array storing 0 to n minus 1, and then we'll print that. Finally, we'll loop through that and double every element and print that final array. Let us look at the demonstration for this. So if I come over here, now again, there are certain default libraries which you have to import, and IOStream being one of them. There is one more library. You could directly import something called as hash include bits slash stdc plus plus dot h. Now what would this do? IOStream only includes one library for input output. If you want to use all the libraries available in C++, you can include this, and just avoid importing everything other manually. So yeah, if you are doing competitive programming, or if you are doing something like that, you would usually import this. For this for the current program, let's not do this, and so you'll do something using namespace std. What does this do? Again, ignore this part. Just understand this is something which is required to make our further code simpler. If you want to know how this works, you can check it out separately, or you can reach out to us. We'll explain that. Int main, again, at this point, I think everyone knows that. I think you would have studied C. So the entry point of our main program is this. And at the end of our program, since it is an integer type, I return 0, which means everything was working fine. Starting ahead. So first, what do I have to do? I have to read n. For that, I'll declare a variable n, and this is the syntax for reading. So with this, I will read that value n. Okay. Let's say to do this, I'll do something like cout, and then I'll write enter n. Okay. So this will ask me to enter n, and then I'll read that. What do I do next? I have to create an array, right? Create an array of n whole numbers. Now, how would I do that? Let's say first I'll declare my array int arr, and what would be the size? It would be n. Okay, and yeah, so this is my array. What would I do next? I would run a for loop. I set this to 0, and then after this I will run my loop until n less than n. As mentioned, I think you know the reason, because n minus 1 is the last position of my array, and I'll put an incrementer I plus plus. What would I do now? I'll open my brackets and I'll do something like this: arr of I is equal to I. This takes care of this. And what do I do next? I'll have to print this. So I'll write something like print array. So after this, I'll run a for loop. And okay, before that, I'll write something like this: elements are such. Int I is equal to 0, I is less than n, I plus plus, and with this I'll print that value. So let's say this was my first part as per my question. Okay, so there's a semicolon over here, all right, and yes, let's say I enter 5. This, okay, I should add space as well. I'll add an empty character as a space. So if I run this and I enter 5, I get 0, 1, 2, 3, 4, which were my first whole numbers. As per my second part of my question, I should double these. So how would I do that? I'll write something like double array elements. And by the way, these double slashes are used to put comments. Comments are not printed. That's just for your own understanding. So I'll do something for int I is equal to 0, I is less than n, I plus plus. What would I do now? As I showed in my syntax, I'd use this arri is equal to 2 times of arri. So arri is equal to 2 into arri. There are shorthand methods to do this as well, but I'm not using that over here. Okay, so moving ahead, let's say I'll write count, which is basically, the printout statement, and then endl to add a new line before the next line. And after that, I'll mention, let's say, array. And now what will I do? Let's say I'll copy the exact same piece of code. I'll come over here and I'll print that. I'll write that. So if I do this, what will I get? Let's say if I write 5, first I got 0, 1, 2, 3, 4, and then I doubled those values and printed those 0, 2, 4, 6, 8. So this is a simple demonstration of a simple program. Moving on, if I go to talk about the time and space complexity, I did teach time and space complexity before this. So if I talk about my space complexity, I am using an array int arr, right? So this will contribute a size of n space. I'm also reading a variable n. What does this mean? My space complexity is O of n plus 1. I'll drop this constant, and so my space complexity is O of n, like mentioned over here. About my loop, uh, about my time complexity, I'll read one value once, then I'll run one for loop for n times, another for loop n times. So there are 4 for loops running n times, and I'm also printing some things. So let's say enter this, print this, print this, right? So one step, so there are like 1, 2, 3 print statements, and one, for reading. So that would be around 4 steps, plus again we are running a loop for n times, and such there are like 4 such loops. So we are running 4n. So if this was my complexity, I'll avoid this value, and I'll ignore this constant as well. So I'll get something like O of n. So that covers my complexity. Does anyone have any questions at this point? Yep. Someone wants to. Yes, Sinchana. What is the question? Uh, can you speak? No. All right. What about you, Vikas? What was your question?
In program used int main, right? What does it do, int
Yeah.
main?
Yes. So main is the entry point of my program in C++. So whenever I run my file, main specifies that this is the main function of my program. Can you please run this? Now, what does int do? Int is the data type. Again, don't go too deep into why int, why void. There are different ways to write this. There are for main function primarily you will use void and int.
Yes.
Ignore that for now. Yeah, just remember that main is your entry point. Is that
Okay.
fine?
And
Yeah.
in that program void main.
Yes. If you write void main, then you don't have to return anything. Then you can skip the return zero
Oh,
statement. Is that fine?
uh,
It's just that when we write return zero with int main, it is a way for me to know that my code is working properly. If I do void main, my code could be running, it could do everything, but I won't know if it did it properly. With int main, if my code runs properly, I get a zero as return value. If not, I get some other value. That's the reason why we use int main in practice. Is that fine?
okay. 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 Here
Yeah.
int main
uh Riddhima, about yeah, go on. Yeah,
Yeah,
because
int
go
main
on.
is like in code if you type return zero, right? So it
Hmm.
will give zero and it won't give try other value, right?
Yes, that is if my main is working properly, if my program was faulty, if it exited because of any reason, right? Because of, let's say, some error. In such a situation, I wouldn't get a zero in return. Is that fine?
Okay, okay.
Yep. Moving on to Ridhima's question, can you explain? Okay, what accounts to, okay, Kushal, what accounts to time complexity, input, printing, and what else? Right. If I talk about time complexity could be because you are reading something, you are processing something, and you are writing something. In a program, these are the only three things which you do. You read, you process, and you write. All other things are actually a mix of these. So for reading something also, you're processing, right? You're processing, let's say, through an array, something like that. So these are the main three things. Again, you have to dissect separately. There are programs where each part contributes to something specifically separately. You have to check, what am I doing? That is why when I wrote the steps over here, I explained these are the main things which contribute to my program. So one is reading, another is creation and filling, next is printing, again it's looping, and again it's updation. Why did my time complexity for the program increase compared to this one? Because I was using some print states, key enter value, print value, for simplicity and for making it easier to understand. Is that fine? Okay. Now, Ridhima, your question, can you please explain space and time complexity analysis of the code again? Yes, I can do that. If you look over here, what did I say? What contributes to your time and space complexity? Space complexity is due to storage space, right? So, reading a value n, I'm also having an array over here. These are the two things which are contributing. Now, this integer n is just a variable. This is contributing O of one space as mentioned in the rules. This array is actually storing those n values. So this is contributing O of n space. So what do we have? We have O of n plus 1. Okay. And what happens? As I mentioned, you drop the constant value. So you get rid of this one and you end up with only O of n. So this is about the space complexity. About the time, time, as I mentioned, could be due to reading, processing, and writing. If I check over here, I read one time and I print like one, two, and then one more, three times, right? So one C out, two C out, and then three C out, and then one C. These are the four statements for reading and writing. Again, each such statement only contributes one step. So O of 1 plus 1 plus 1 till 4 times gives O of 4. After that, I am running a loop. Okay, you might be concerned that all this should also contribute, right? In practice, we try to avoid that. We don't consider this. We only care about what is actually going inside. So if we look at how many times this statement runs or the body inside the loop runs, this statement runs n times 0 to n minus 1. So n minus 1 minus 0 plus 1, which is, standard way to calculate the number of steps, is n. Again, this runs n times, this run n times, and this run n times. So what would I have? I would have something like O of 4n, because there are 4 loops running n times each, plus 4 steps from reading and writing. As mentioned, drop this value because that's very small compared to n, and we drop the constant as well. So this is how we end up at O of n time complexity. Does this clear it out? Yes, Sneha, int I will also contribute to space and time. But as I mentioned, these are temporary, these are constants, right? As I mentioned, when I write my space and time complexity, I only mention the order, the highest contributor. If I add that, for example, that would add to some, like, let's say 4 more spaces, right? So it would be O of n plus 5. Again, I am not concerned about that. I can drop that. I only care about O of n. The reason why we don't write that as one of the contributors, but I mentioned the one above, is that that is, a more important factor, deciding factor over here. Does that make sense? But yeah, if you are being asked about the true time complexity and space complexity, you have to take into account every single thing. On the other hand, for near about, you can follow the method I did. Okay. ARR star equals to is the shorthand you mentioned. Yes, Pranay, that is the shorthand. So I think this covers the doubts for this problem. So I'll move on to the next one. Guys, it's already 7:30. Do you want me to continue or do you want to move on to the quiz? There is one more problem. Please type in the chat. I know it went a little beyond the prescribed time, but that was because we had to talk about a few introductory slides as well. Please respond in the chat in case you want me to continue. Quiz. All right. Do keep this in mind that our quiz was designed specifically keeping the questions which we do today in mind. Enough for today. Okay, all right. We'll wrap it up over here and we'll move on to the quiz. I'll stop sharing my screen for a moment. In case someone wants to, know what was over there, you can take a screenshot of this. Please take a quick screenshot. I will share the PPT tomorrow. We will share it. But for now, you can just take a screenshot. I guess this is done. And then this is the next one. The question. All right. So moving on, I will move on to the how many people do we have? Okay. I'll stop sharing my screen for a second and I'll share a QR code. Just not a QR code, a link in the chat. Just join it through your phone or your laptop to take part in the quiz.